So today we will look at what we've learned before. It's called indefinite integral when we're doing anti-differentiation. Today we will learn about definite integral and the fundamental theorem of calculus. What it is. If we have this symbol called integral, that's why it's called integration, we call the anti-differentiation. And if we have that antiderivative of function f of x dx equals f of x plus c, then the definition of the definite integral, we write integral and we put limits, lower limit and upper limit. Let's say you can see the x squared minus 4 from minus 2 to 2 dx. So difference is there is no numbers here. We're finding function. What function was differentiated to obtain this function? In this case, we're finding it called definite integral of this function from minus 2 to 2. And the definition is from a to b, integral of f of x dx equal value of the antiderivative function at b minus value of the antiderivative function at a. This expression called fundamental theorem of calculus and pretty much define what is definite integral is. And let's apply this to this example. So what is antiderivative of x squared minus 4? Come on, it should be easy.
X cubed on 3.
3 minus 4x.
X cubed on 3 minus 4x.
Plus it.
Now, we don't write plus c here,
Yes.
because we have plus c and then minus mc, it cancels out. Then we put it into the square brackets, and we write minus 2 and 2, lower limit and upper limit. Then we substitute 2 instead of x, so will be equal 2 cubed over 3 minus 4 times 2. So that the value of the antiderivative function at x equals 2. And we minus value of the antiderivative function at x equals negative 2. So we have negative 2 cubed on 3 minus 4 times negative 2. When you will be doing that, don't forget to put value of the antiderivative function at a. Yeah, thank you.
Yeah, should be fine.
Thank you. So, when you minus in value of the antiderivative function at the lower limit, always put this in the brackets. Otherwise, it's high chance that you will mix up with this sign when you will be calculating the number. So put f of a in the brackets. Equal 8 on 3 minus 8 minus, we have minus 8 on 3 and plus 8 equal, expanding brackets, we get 8 on 3 minus 8 plus minus minus plus 8 on 3 minus 8 equal 8 on 3 plus 8 on 3 will be 16 on 3 minus 16. 16 on 3 minus 16 will be equal 32, negative 32 on 3. So value of the definite integral of x squared minus 4 equal negative 32 on 3. So when we calculating the definite integral, the answer will be number. No, it can be in terms of the parameter, if we have, let's say here, a or involved or something like that. But generally saying, if it's lower limit, upper limit are numbers, definite integral will give us a number. Make sense?
Yeah.
Now, where it's used. Main or very important application that using definite integral we can find the exact areas. Last lesson we've learned about finding the estimating of areas using the rectangular or trapezium estimations. Now let's say we want to find area enclosed between y equals x squared from negative 2 to 3. So we want to find the exact value of this area.
Oh, is that why you did the domain? Like between -2 and 3?
Yeah, we want to find area enclosed between the graph y equal x squared and x-axis from negative 2 to 3. So we find a definite integral from negative 2 to 3 of x squared dx equal x cubed on 3 from negative 2 to 3. Substitute upper limit, so it will be 3 cubed
27.
over 3 minus value of this antiderivative function at negative 2 minus negative 2 cube divided by 3 equal 27 over 3, 9, and minus 8,
Plus 8.
but minus plus 8 on 3 will be equal 35 on 3 units squared. So that will be exact value of the area enclosed between the curve y equals x squared and x-axis. Make sense?
Yeah.
Now, when we calculated in the previous example, when we calculated the definite integral for x squared minus 4 dx from negative 2 to 2, we got negative number. But can area be negative?
No.
So when we find in the area, to sketch the graph of x squared minus 4, so this is negative 4, will be 2, negative 2, and this is this parabola. And what we find an area enclosed between the graph and x-axis. But if you calculate just definite integral, we get negative number, but area cannot be negative. So if graph is below x-axis, for that part, we take the definite integral with a minus. So in this case, area will be equal negative integral from minus 2 to 2 x squared minus 4 dx.
So it ends up cancelling out and being positive.
And it becomes positive.
Okay.
Because when you calculate definite integral for the function that is below x-axis, it always will be negative number. If it's above x-axis, you will get positive number. Below x-axis, you get negative number. But to get area, we take this with the minus. And now one more property of the definite integral. We have integral from a to b of fx dx equal negative, and we swap the limits. So you can either put minus at the front or you swap limit.
Is the top limit always the lower one, or the lower?
Yeah, we usually this is smaller number, this is bigger number. But if we swap, the value change to opposite.
Yeah.
Now, when we calculated just that integral without minus, what we got in the previous
Negative 37.3.
negative 32 and 3. Not from x squared, but previous one is
Yeah, it's
negative 32 and 3.
Negative 33.
So it will be equal negative 32 on 3. So equal 32 on 3 square units. Make sense?
Yeah, that makes sense.
Now more complicated example. When we have part of the graph is below x-axis, part of the graph above x-axis. So let's consider function y equal x times x squared minus 4. It is a cubic function. If we expand the brackets, we get x cubed minus 4x. If you sketch a graph, what will be the x-intercepts of this? Look at-
0, 2, and negative 2.
Yes, the x-intercept will be 0, negative 2, and 2. And because cubic term is positive, the shape of the graph, of the cubic graph, will be like this. So we have that it will go this, and like this. And if you're looking to find area enclosed from minus 2 to 2,
Would you do
between
minus-
the graph and x-axis,
Would be minus 2 to 0. Oh no.
we break it in two parts.
Minus 2
That
to 0 and 0.
area will be equal antiderivative. This is above x-axis,
So it's probably.
from minus 2 to 0 of x cubed minus 4x dx minus integral from 0 to 2 x cubed minus 4x dx.
Then you
So
plus
we
the-
break it in two parts. We take this part with positive sign, and what is below x-axis we take with the negative.
Yeah, okay. And then you add them together.
And then we just calculate, we get this antiderivative will be x in the power of 4 over 4 minus 4x squared on 2, so minus 2x squared from negative 2 to 0 minus same expression x in the power of 4 over 4 minus 2x squared from 0 to 2 equals, substituting 0, it's all 0. So you'll have minus, we substitute minus 2, so we will get minus 2 minus 2 in the power of 4 is 16. 16 on 4 is 4. And minus 0, value at 0 is 0. minus 4 minus 2 squared, 4 times 2, 8, so minus 8. That is this part, minus, we substitute in 2, we get 2 in the power of 16 over 4, minus, again 2 in the power of 2, 4 times 2, 8, 4 minus 8, minus 0. Because when we substitute 0 is 0, equal, that becomes minus 4, but minus minus, positive 4, and this will be negative 4, but with a minus, plus 4, so equals 8 units squared. So this area equals exactly 8 square units. Make sense?
Yeah.
That's all of the theory. Now let's do some practice.